This is section 2.1 on the distance and midpoint formulas. So starting with the distance formula, the distance between any 2 points, they call the first point P1, where the 1 is a subscript, it's below ground level, is x1, y1, and point 2, or P subscript 2, is x2, y2, denoted by D for distance of point 1, point 2, is the following formula. So whenever it asks you to compute the distance, this is the formula you can plug into every time. Big old square root symbol. Parentheses, you're going to take the second x coordinate, which is x with a 2 subscript below it, minus, you're going to take the first x coordinate, which is x with a subscript of 1, that quantity squared raised to the second power, plus you're going to mimic the same pattern for the y's. Y sub 2, which is the second y coordinate, minus y sub 1 quantity, also squared raised to the second power. Now as you're looking at this formula, a lot of times people ask me, well, doesn't a square root get rid of the squares? In this case, no, because there is a big old plus symbol trapped under the square root. So you can only apply square roots if you have multiplication only going on under the square root symbol. So in other words, if you have addition or subtraction in between squares like this, under a square root symbol, you are stuck with the square root symbol because of that plus symbol. Okay, so let's see this formula in action. After we use the formula, you are going to want to simplify the square root answer as much as possible. So looking at, it's called example 2, it's actually technically example 1. I took this off of the packet for the face-to-face version of this course. But looking at example 2, it says find the distance between the points 5, negative 10, and 3, negative 1. So pick either point and call it the first point. So the first point we saw was 5, negative 10. So I'm going to call that the first point. So the first x coordinate was 5. So x sub 1, as they label it notation-wise, is going to be 5. The first y coordinate, or y sub 1, is negative 10. The second point I'm going to call the 3, negative 1, simply because I read it second in the sentence. So 3 is the second x coordinate, so it's x sub 2. Negative 1 is the second y coordinate we encounter, so that's y sub 2. Now, just simply plug into the distance formula whenever it asks you to find the distance. In other words, what's going on here is if you were to plot these 2 points they've given to you, and you were going to draw a straight line segment between the points, they want you to calculate the exact distance between those 2 points, so the length of that line segment. So here we go. I'm going to draw my big old square root symbol first. It says parentheses, start with the x2, the second x coordinate, which was 3, minus, according to the formula we minus, x sub 1, which was 5. Close the parentheses, and it's squared, raised to the second power. There is a plus symbol in between everything, according to that formula above. Parentheses again. Now it wants you to do y2 next. So y2 was negative 1 minus y1, which was negative 10. And that also needs to be squared. So your first step is to plug into the formula. Then you want to use order of operations to get it down to one number under the square root symbol every time. So for now, just keep bringing that big old square root symbol along for the ride. So order of operations, you got to do what's inside parentheses first. So inside the first set of parentheses, I got a 3 minus 5, which is negative 2. And I'm going to leave that answer in parentheses because it's a negative answer. It still eventually needs to be squared. Bring over the plus symbol in the middle. Now in the second set of parentheses, we have a double negative in the middle, minus minus. Negative times negative is plus. So whenever you have two negative signs sitting side by side, it becomes plus. So I'm going to make the two minus signs into a big plus symbol. So I actually have -1 plus 10, which is +9. And it's going to be squared. So now that we've done what's inside parentheses, my next step is exponents. Think a good old PEMDAS, or please excuse my dear Aunt Sally. So again, just don't forget about that big old square root on the top. If I do -2 squared, notice I am squaring the negative sign. So this is actually -2 times -2, which is +4. Bring down the plus symbol in the middle. Now let's do 9 squared, or 9 times 9, which is 81. After you do the exponents, the only thing left under the square root symbol is the plus symbol. So now I can do 4 plus 81, which is 85. Let me go ahead and do a little bit of erasing, and let's move this answer up. And I'll fix my formula as well. But so far, I got it down to one number under the square root. I have square root of 85. And let's put the formula back in here. I erased a little bit of that y. There we go. Okay, so now you're not done yet. You have to always check whenever you have a square root answer at the end, always check, can I simplify this square root further? So you're going to use the algorithm from the last video on simplifying square roots. So to find out if you can simplify the square root further or not, draw a prime factor tree for the number under the square root symbol, which is 85. So we pick any pair besides itself and 1. So 85, it ends with 5, so it must be divisible by 5. So if I divide by 5, I see that 5 times 17 gives me back 85. 5 is prime, 17 is prime. My factor tree is done because I have every branch ended with a circled prime number. However, I do not have any matching pairs of the same number. So that means I cannot simplify the square root of 85 any further. So the square root of 85 is the final answer for example 2. But you should check every single time you end with a square root number if you can simplify further or not. Let's try one more. Example 3 says to find the distance between the points -2, -1 and 2, 3. So it is going to be the distance formula yet again. And let's go ahead and label our points. So the first point I saw was -2, -1. So the first x-coordinate, or x1, was -2. The first y-coordinate I saw, or y1, was -1. The second point I read in the sentence was 2, 3. So x2, the second x-coordinate, is 2. Y sub 2, the second y-coordinate, is 3. Now we plug in to the formula at the top of the screen. So let's write the big old square root symbol, parentheses, x2 it wants us to start with, x2, the second x-coordinate was 2, minus, according to the formula, x1, which was -2. Close the parentheses, it's squared. Don't forget about the plus symbol in the middle of everything. Now, same pattern for the y's, parentheses, y2, the second y-coordinate was 3, minus y1 was -1, close the parentheses, it's also squared. After you plug into the distance formula, time to use order of operations to get it down to one number under the square root symbol. Doing inside parentheses first, I see minus minus, which becomes plus. Same is true for the other set of parentheses. Minus minus, double negative becomes positive. So I have 2 plus 2 for 4, which will need to be squared. Bring over the plus symbol in the middle. We haven't touched yet. The other parentheses, I have 3 plus 1, also for 4, still needs to be squared. After you do inside the parentheses, now do the exponents. So 4 squared gives 16, because it's 4 times 4. Bring the plus symbol down, we have another 4 squared for another 16. Add after you do the exponents, so now I'm going to do 16 plus 16, which is 32. Notice I keep bringing down that big old square root symbol with every step that we haven't touched yet. I'm going to erase to create some more room. Let's move the square root of 32 up here. The square root of 32. If I typed that into the MyMathLab answer box, it would say wrong because I haven't checked it yet to see if it simplifies. So we're not done yet. We got it down to one number under the square root. Take the number under the square root and draw that good old factor tree. So 32, I got lots of choices here. I'm going to go with 4 and 8. And then 4 is 2 and 2. 8 is 2 and 4. And 4 breaks down further into 2 and 2. So 32 breaks down into 1, 2, 3, 4, 5 2s. We have a couple of matching pairs of the same number. So that means we can simplify the square root of 32 further. So I'm going to leave a little bit of room. And let's rewrite 32 as 5 2s. 1, 2, 3, 4, and 5. Now for every matching pair of 2s, we bring out one of that number. So I've actually just did the square root of 4, which is 2, times. I have another matching pair of 2s, so another 2 comes out to the front. The theme is multiplication. So now I can do the 2 times 2 that's in front for 4. There is one remaining 2 to bring down under the square root. So the exact distance would be 4 times the square root of 2 for the final answer. So that's the distance formula. Plug in, simplify. The remaining questions on this homework are going to deal with a totally different formula, which is the midpoint formula. So if I look around the middle of the screen here, this is a midpoint, capital M, which is going to be a point. So you can think of this as two answers. You're going to have parentheses around your answer because it is representing an ordered pair of point. You're going to have a comma in between. You're going to have an x coordinate and also a y coordinate. So that's why it is kind of like two answers. You're going to have to figure out the x coordinate of the midpoint and the y coordinate of the midpoint. Of the line segment from point 1, which is x1, y1, to point 2, which is x2, y2, is the following formula. So let me jot down that formula for midpoint. So all you're doing to find midpoint is you're going to find the mean average a couple of times. So parentheses, you're going to first figure out the mean average of the x coordinates. So you're going to take x1 or x sub 1 plus x sub 2, the second x coordinate. So add your two x coordinates together. And because you're finding the mean average, you're going to divide by 2 because you're adding two things together is why you're dividing by 2. Comma, same pattern for the y's. You're going to take the first y coordinate, y sub 1, and you're going to add it to the second y coordinate, y sub 2, and also divide by 2. I am using fraction bar for division. If you do end up with an improper fraction at the end, they want you to leave it as an improper fraction. They prefer that over a decimal, just as a heads up. So looking at this formula in action, and by the way, notice you do not subtract at all, nor do you take square roots at all with this formula. So example 4 says to find the midpoint of the line segment from point 1, which is negative 5, 5, to point 2, which is 3, 1, plot the points P1 and P2 and their midpoint. So it is literally the middle point, the halfway point you're finding. They're giving you 2 endpoints, and if you were to draw a straight line segment, we're trying to figure out what is the middle point here. So they gave us point 1. So x1, x sub 1 is negative 5, y sub 1 is 5. They gave us 0.2, the second endpoint. X2 is 3, y sub 2 is 1. And they're asking you for midpoints, so just simply plug into our new formula. So parentheses says x1 first, which was -5. And we're going to add it to x2, which is 3. Then we're going to divide by 2, always dividing by 2 in this formula. Comma, now let's do the same thing with the y's. Y sub 1 was 5, plus y sub 2 is 1, and we're going to also divide that by 2. And so now let's simplify. So let's add the numbers on top first. So when I do -5 plus 3, I get -2. Don't worry about dividing by 2 until the end. Comma, and then I have 5 plus 1 for obviously 6 here. Just bring over the division of 2 for now. So now let's see if we can simplify. So we said we divide by 2 last, if it is divisible by 2. Here it is, -2 divided by 2 is -1, comma, 6 divided by 2 is 3. So I get a final answer of -1, 3. Let me erase and move that answer up. So -1, 3, final answer for midpoint. Don't worry about plotting the points. The homework doesn't have you plot them, so I'm not really worried about that. I'm more concerned with, like the homework is, can you find the midpoint? Can you simplify it? Use the formula, simplify, done. You're good to go. Looking at example 5, it says to find the midpoint again of the line segment from point 1 is now 4, 1 to point 2, which is 5, -4. Don't worry about plotting the points. Trying to make this as close to what the homework's going to give you as possible. So using the formula again, midpoint formula that is, point 1, x1, y1 is 4, 1. Point 2, x2, y2 is 5, -4. Here we go. So start by adding your x's. x1 was 4, plus x2 was 5, always dividing by 2, comma, y1 is 1, plus y2 is -4, and we divide by 2 again. Close the parentheses. Now add the numbers on the top next. Let's erase a little bit so I can see this better because I'm already running out of room because I have such big handwriting. 4 plus 5 for 9. Bring over the division of 2, comma. 1 plus a -4 is the same as 1 minus 4, which is -3 over 2. Neither of these numbers are divisible by 2, nor do they reduce at all. So these are improper fractions because the numbers are bigger on the top. However, we said that my Math Lab homework prefers improper fractions over decimals. You can use the fraction bar from the answer template to get those fractions into the answer box, and you can just use the parentheses and the comma from your normal keyboard to get those in. But final answer here is 9/2, comma, -3/2. I did want to do just one more example because I get asked a lot about this. So let's say that we want to find the midpoint again. And just keep in mind the formula for midpoint. You add the x's, you divide by 2, then you add the y coordinates, and you also divide by 2. But let's say that for the end points, they give you the following. Let's say that point 1, they give you A, B, so they give you letters. And for point 2, they give you the origin, which is 0, 0. So let's go ahead and use the midpoint formula when you have variables combined with the number 0. And let's see what that looks like. So when we label the first point, x1 is going to be A, y1 is B, x2 is 0, y2 is 0. So let's see what happens here. So parentheses, we're going to add the x's first. So x1 was A, plus x2 is 0 divided by 2, comma, y1 is b plus y2 is 0, also divided by 2. So it's the simplifying step right here that sometimes can be a little bit tricky, because normally we're taught in algebra you cannot add a letter to a number. They're not like terms. However, think of 0 as a concept more than a number. So if I'm saying take something, we'll call it A, and add that something to nothing, you get back the original something. So if you have any letter plus 0, you can simplify it to just that letter back again. So in other words, A plus 0 is just A. So you can just get rid of the plus 0 is what I'm getting at here, and bring down the division of 2, comma. Same idea with B plus 0. B plus 0 would also just be B, and bring down the division of 2. And then this would be the final answer, A over 2, comma, B over 2. I apologize, my A looks a little weird there. I promise that's supposed to be a little A on top of the first fraction, but you get the idea. Letter plus 0 gives you back the original letter again.